Video will serve as a review of finding the domain and the range for continuous as well as discrete graphs. The first graph that we're looking at is what we would call a discrete graph, meaning that I'm able to count all of the points. The points are not connected. I can actually count the number of points that are on the graph. So in order to list the domain and the range, I need to first identify the XY ordered pairs associated with each plotted point. And you all are capable of doing that, but I'll go ahead and mark it on the video. Okay, so those are my points. To list the domain and the range, the domain would just be the set of an x value, all of my x values. So my domain is going to be, and did I miss a point? Yes, I missed one point. This is the point 4, 6. Okay. And let's see, my domain, order doesn't matter. Numerical order does not matter. That's just a list of all of my x values, and then my range would just simply be a list of all of my y values. And if I wanted to just discuss the vertical line test, if I cannot connect two of the points together to create a vertical line, then I would assume that this is a function. And as I look at this, there are no vertical lines that I can connect, so I would say, yes, this is a function. Just to go ahead and add that piece in. And let's look at the next graph. The next graph is a continuous graph. And I'll just go with number 17. This is a continuous graph. Notice that number 17 has a definite stopping point. So let's plot the ordered pair associated with this. And this is going to be the ordered pair positive 2, positive 1, right here. Positive 2, positive 1. And notice that I'm going off in the direction of the infinities. That's what the two arrows are telling me. So let's see, domain. The domain associated with the x-coordinate, the range associated with the y-coordinate. The domain is going to be starting in the direction of negative infinity, coming up to positive 2 and stopping. And I'll make that a hard bracket because the curve is solid black at that point, at that turning point. So I'm assuming that that point is on the curve. And as far as an inequality goes, all of the x values are less than or equal to positive 2. To look at the range, and I'll change colors. To do the range, I'm only concerned with the y values. So my range will be very much the same, negative infinity, coming up to positive 1 with the hard bracket. And then I'm going to use the variable y for my range. All of my range values are less than or equal to positive 1. As far as the vertical line test goes, if you're able to draw vertical lines through the graph and intersect the graph in more than one spot at a single time, it is not a function. So this is not a function because it fails the vertical line test. Fails, and I'll just use the initials VLT for vertical line test. And let's see, number 19 has a definite starting point, has a definite peak, and this is going to be the ordered pair 1, 2. X-coordinate, Y-coordinate. Noting that I've got the arrows going off the paper, or off the grid rather, telling me that this shape is going to continue to grow. So let's do the domain, let's do the range. Let's see, it looks like horizontally, this graph looks like it has no bound. Looks like it's going to continue to grow horizontally in both directions. So I'm going to say that my domain is all real numbers. But my range, however, it looks like I've got a maximum point right up here at the top. So for my range, being concerned with my y values only, it looks like positive 2 is going to be at the top of this graph vertically. So it looks like my range is going to be negative infinity, coming up to positive 2, soft bracket hard, and then I would say that all of my y values are less than or equal to positive 2. As far as the vertical line test goes, if I try to draw vertical lines through this graph, see that I can only intersect the graph in one spot at a time with my vertical line. So this graph passes the vertical line test, therefore I consider this a function. This is a function. And looking at the graph below, okay, so the graph below, I've got the arrows going off the grid, which is telling me to assume that this pattern is going to continue off the grid. And I'm going to assume, let's see, with this particular graph, I think I'm going to assume that it's all reals because I've got a top point here, but the arrow already surpasses that top point. So I'm thinking that this graph is only going to curve and view within what I can see. And then over here, I do have a low point, and the graph appears to stop before I can make an assumption or an assessment about that. But my instinct tells me that this graph is going to be all reals in both directions. I think that this is a little ambiguous right here. And had they at least plotted one more low minimum point, then I would have been able to make an assumption about whether or not this graph is going to repeat. But the way that it's presented, I'm going to assume it's all reals in both directions. It's going to grow without bound. I'm going to make that assumption. It's going to grow without bound in both directions.